Hi class, today we're going to solve systems with three variables, and this is part 2 of what we did for our last section. Again, we're solving systems with three variables. Last time we were working on elimination, so this time we'll be working with substitution. Alright, in example 3, we're asked to solve a system using substitution. If we can recall back in previous sections when we were asked to solve using substitution when there were just two equations, we first decided to look for the single variable. We would look for the single variable and then choose to isolate that variable. After we isolated that variable, we would then substitute it into the equation to get one answer and then take that answer and substitute into the other. Well, that's essentially the same thing we'll do here, except we have three equations. So let's first start by looking for a single variable. I have identified the single variable as x right here. Okay, so we'll first start by writing that equation, or excuse me, isolating x. So we have x plus 5y equals 9. If I subtract 5y on both sides, I will have x equal to negative 5y plus 9. Alright, now I'm going to take this x variable and I'm going to substitute it into the first and the third equations. So let's see what that looks like. Okay, in the first one, I will have 2 times negative 5y plus 9 plus 3y minus 2z equal to, okay, this isn't working, equal to negative 1. Okay, if I distribute the 2, I get negative 10y plus 18 plus 3y minus 2z equal to negative 1. Alright, on the left hand side we need to combine like terms, and I also need to move my 18 over. So if I combine like terms, I have negative 10y and positive 3y. That will make negative 7y. I also have a negative 2z. And I need to move my positive 18 over by subtracting 18. So negative 1 and negative 18 will make negative 19. Alright, so that's my first fixed equation. Now again, we're going to deal with this one here. Okay, so I need to substitute negative 5y plus 9 into the third equation. So that will look like 4z minus 5 times negative 5y plus 9 is equal to 4. Okay, we're going to distribute that negative 5, so we'll have 4z plus 25y minus 45 equal to 4. If I add 45, I will have 4z, and let's go ahead and put this in alphabetical order so to make it easier for us. So I'll make that 25y plus 4z is going to be equal to, remember I'm adding 45 over, so it's going to be 49. Alright, so just like in elimination, at this point we take our two equations, our two fixed equations, and we're going to put them together to eliminate another variable. So here we go. I'm going to go ahead and just move, actually I'll just rewrite them in the center. Here we go. Negative 7y minus 2z equals negative 19, and 25y plus 4z equals 49. Okay, so we have to choose at this point to eliminate a variable. I see that the z's are easier to eliminate because I can, I'll notice that my least common multiple is 4. So I have a positive 4 on the bottom, so I'm going to multiply the top by 2 so that I have a negative 4 on top. So let's rewrite. We should have negative 14y minus 4z equals negative 38. And we should have 25y plus 4z equal to 49. Okay, the z's are gone, and I'm left with 11y equal to 11, so y must equal 1. Okay, that's the first, that's our first answer. Okay, now I'm going to take that y equal to 1 and substitute it into one of our pink equations. I'm going to put it into the first one over here because they're all positive and it looks a little easier over here. So here we go. So 25 times my y, which is 1, plus 4z is going to be equal to 49. So that's 25 plus 4z is equal to 49. If I subtract 25 on both sides, I'm going to have 4z is equal to 24. So z is going to be equal to 6. All right, the last one. Now that I have y and z, I need to substitute that into the first equation because the first equation is the only equation that has all three variables. All right. Okay, so when I substitute y and z into my first equation, I'll have 2x plus 3 times 1 minus 2 times 6 is equal to negative 1, which is 2x plus 3 minus 12 equals negative 1. 3 minus 12 is negative 9. If I add 9 over, we're going to have 2x equal to 8, so then x equals 4. And remember, our final answer has to be written as a point, so that point will be 4, 1, 6. And that's our final answer. We're going to practice this again on our try. Okay, so we're going to do this again on try 3. Again, the first step with substitution is to identify the single variable. Here we have a lot of choices, right? In the first one, I could choose to solve for or isolate that x variable or the z. I could choose in the second one to isolate the y, or in the last one, I could choose to isolate that z, which I wouldn't choose that z there because it's negative. So we just need to go through and determine which one we want to isolate. I'm going to make it kind of easy, I guess. I'm just going to choose the first x at the very top. I'm going to choose this x at the very top to solve for. Because in my mind, mentally, I can move the other two over in my mind and just change the sign. So that will look like x equals, if I've moved negative 2y over, it's now positive 2y. If I move if I move positive z over, it's now negative z, and I still have negative 4. Okay, so that's what I'm going to substitute into the second and the third equations. All right, so here we go. If I substitute into the first equation, I will have negative 4 times my x, which is 2y minus z minus 4, plus y minus 2z equals 1. Okay, and then we need to continue to simplify. So if I distribute the negative 4 to everything in that set of parentheses, I'll have negative 8y plus 4z plus 16 plus y minus 2z is equal to 1. Okay, on the left-hand side, we need to combine our like terms, and I need to move my whole numbers to the right. So let's combine like terms first. I need to get my y's together, so I have a negative 8y and a positive y. That would give me negative 7y. As far as my z's go, I have a 4z and a negative 2z. That would give me 2z. And then this positive 16 needs to move to the other side. So that means I need to subtract 16 from 1. Okay, so 1 minus 16 is going to be negative 15. So that is my first equation. Okay, I need to fix the second one, so I need to substitute 2y minus z minus 4 into the last equation. So it will look like this. 2x, or 2 times 2y minus z minus 4 plus 2y minus z equals 10. Okay, I need to distribute the 2. So I will have 4y minus 2z minus 8 plus 2y minus z equals 10. Again, I need to get my y's together. So I have 4y and 2y, so that would be 6y. I need to get my z's together, so that's negative 2z and negative z, so that makes negative 3z. And And I need to go ahead and move my -8 to the other side. So that means I need to add 8 on both sides. So 10 plus 8 is 18. All right, now that I've fixed those two equations, I'm going to put them together in the center. So let's do that. -7y plus 2z equals -15. And the second one is 6y minus 3z equals 18. All right, right off, I'm going to go ahead and choose to eliminate z because the least common multiple there is 6, whereas the least common multiple for y's is 42. So if I want to choose 6 as my least common multiple for the z's, I need to multiply my top by 3 and my bottom by 2. So when I rewrite, I'll get -21y plus 6z equal to -45. And for the bottom, I have 12y minus 6z equal to 36. Z's are gone. I'll be left with -9y equal to -9, so y equals 1. That's our first answer. Now that we know that y is going to equal 1, I'm going to go ahead and substitute that back into this equation over here on the left. So that will read 6 times 1 minus 3z is equal to 18. It says 6 minus 3z is equal to 18. If I subtract 6 over, I have -3z equal to 12. If I divide by -3, then z will equal -4. Okay, last step, I need to substitute x and y into one of my equations. And what I'm going to choose to do is, since I've already fixed an equation, right? I fixed the very first one here, right? Right? That's the only thing that I haven't found is x. I'm going to go ahead and substitute it into there. So x will equal 2 times my y, which is 1, minus a -4, because that's my z, and then minus an additional 4. Remember, this double negative will turn to a positive, and +4, -4 at the end will go away. So x must equal 2. So our final answer is going to be 2, 1, -4. All right, let's move on to our next example. All right, in example 4, it says you manage a clothing store and budget $6,000 to restock 200 shirts. You buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? Okay, our variables will be based on the types of t-shirts, and the types of t-shirts that we have available are t-shirts, polo shirts, and we have rugby shirts. Okay, first, our first equation is going to be all of the shirts, all the types of shirts set equal to the total amount of shirts. So that will be our total equation. So we'll have a total equation. And then we're going to have an equation based on the costs of our shirts, because we have a total cost. So that's total, and then there's cost. So that'll be the second equation. And then the third equation comes from the statement that says twice as many rugby shirts as polo shirts. Twice as many rugby shirts as polo shirts. So that will be our, I guess I can call that like translation, because I need to translate that. All right, so let's practice on writing them, and then we'll solve on the next screen. Actually, yeah, let's practice writing them. Okay, so for the total, we're talking about just the types of shirts. That'll be t-shirts plus polo shirts plus rugby shirts equals the total amount of shirts, which is 200. For the cost, so the cost one, the cost of the t-shirts is $12, so that should be 12t, plus the cost of the polo shirts is 24, so 24p, plus the cost of the rugby shirts is 36, so 36r, is going to be equal to the total amount, which is 6,000. Okay, and then finally our translation statement. It says that we need to have twice as many rugby as polo. Twice as many rugby as polo. So twice polo is going to be equal to our rugby. Okay? All right. So now at this point, we're going to solve using substitution. And right off, it looks very easy to me. And in fact, let me go ahead and rewrite this another way so that it's not so confusing. But R equals 2P. To be honest, spot on. I see that that's the one that I actually want to use to substitute. So I'm going to choose to substitute 2P for R into both of the other equations. Okay, but I'm going to do that on the next screen. All right, so to substitute 2P for R, we're going to substitute that into the second and the first equations. Okay, so the way that'll look is for the first one, I'll have T plus P plus 2P equal to 200. That's going to be T plus 3P is equal to 200. Okay, that's as far as I can go for that one. In the second equation, however, I will have 12T plus 24P plus 36 times 2P is equal to 6,000. So that will be 12T plus 24P plus 72P is equal to 6,000. I go one more step and combine my P, so it's going to be 12T plus 96P is equal to 6,000. All right, so let us put these two equations together to solve. So actually, I guess I could have just stacked it under. So I'm going to move this under here. So 12T plus 96P equals 6,000. Okay, off the top, what looks easiest to me is to eliminate the T's. So I'm going to eliminate the T's by multiplying the first one by negative 12. So that will be negative 12T minus 36P is equal to negative 2,400. For the bottom one, again, it's the same. 12T plus 96P is equal to 6,000. T's are gone. I am left with 60P equal to 3,600. If I divide by 60, P is going to equal 60. Okay, now that I got P equal to 60, I need to substitute that. And honestly, I can substitute that back into the R, the original R, right? So here, now that I know that P is 60, I can substitute it there. So that means that R equals 2 times 60, which is 120. And now that I know what R and P are, I can add it to the beginning. Or I could just know that there are 200 original shirts. So 200 minus 120 minus 60. So really I'm saying 200 minus 120 is 80 and 80 minus 60 is 20. So that must mean that there are 20 t-shirts. And that is our final answer. So there should be 60 polo, 20 t-shirts, and 120 rugby shirts. We're going to try one more. It says, suppose you want to have the same number of t-shirts as polo shirts. You can buy 200 shirts with a budget of $5,400. How many of each shirt should you buy? So again, this still goes off of the last problem's prices for the shirts. Okay, it just makes it a little different. So I should be able to fit all this on here. So let's try that. So it's still t-shirts plus polo shirts plus rugby shirts is going to equal 200 total shirts. We have the cost equation is still the same. So that was 12 for t-shirts, 24 for polo, 36 for rugby. But this time we have less money to spend, so that's 5,400. And our final statement is saying that the t-shirts need to be the same as the polo shirts. Okay, and that makes it kind of easy for us because since we know that T is P, wherever we see a T in the first two equations, okay, we're just going to put a P. So here we go. So if I rewrite the first one, I'll have P plus R equals 200. So that becomes 2P plus R equal to 200. That's the first one. Okay, if I fix the second one, that is 12 times P plus 24P plus 36R equal to 5,400, which is 12P plus 24P plus 36R equal to 5,400. That becomes 36P plus 36R equal to 5,400. Okay, so that is the second equation. And again, we'll put those two together. So I'm just going to stack it under here. So it's 36P plus 36R is equal to 5,400. All right. In order to continue to solve here, I'm going to want to multiply my top equation because I'm going to choose to get rid of the p's. So I'm going to multiply the top equation by negative 18 because that'll give me negative 36 to eliminate the p. So here we go. Negative 36p minus 18r equals negative 3,600. And on the bottom, I still have 36p plus 36r equal to 5,400. Okay, the p's are gone. I am left with 18r equal to 1,800. And if I divide by 18, R is going to equal 100. So there will be 100 rugby shirts. Now, if there are, at this point I can kind of use common sense. If there are 200 shirts total and the rugby shirts are 100, that means I have 100 shirts left over. And if t-shirts and polo shirts have to be the same, all I need to do is take 100 and divide by 2. So 100 divided by 2 is 50, so that means that there are 50 t-shirts and there are 50 polo shirts. And that's it.